This video is on how to calculate a descent profile. This is useful not only for instruments, but also in contact. I'm going to get a little nerdy here and reference some high school algebra, a little bit of trigonometry, a little bit of geometry. But I feel that if you understand where the math is coming from, make that connection with previous experience, it'll be easier to remember how to calculate this and how to use this information. So let's start off with looking at a typical descent profile. It's basically a right triangle. If we use an example of the Auger spur recovery. Auger is at 24 DME and I'm at 13,000 feet. Spur is at 10 DME and I'm trying to get down to 2,300 feet. So the altitude that I need to lose is approximately 11,000 feet. And the distance I have to do that in is 14 nautical miles. The angle I'm trying to calculate right here, that angle of elevation. If you remember from your high school algebra, angle of elevation equals my angle of depression. And that's what I, as the pilot, want to know. What is that angle that I need to lower my nose? So this is basic trigonometry. Run through this real quick then. The angle opposite, the one I care about, the 11,000 feet, this is my opposite side. We could also call that the rise. The 14, that is my adjacent side. We could also call that the run. So if you think about your high school algebra, slope, or the steepness of a line, therefore the angle, is simply rise over run. We also think about the great chieftain from the Algebraian tribe. Maybe you know who I'm talking about. That's Chief Sokotoa. So what I have here is the opposite and adjacent sides. So the trig that I want is tangent. So the tangent of my angle is going to be the opposite, or the rise, over the run. Therefore, the angle is the inverse tangent of rise over run. Now, I'm going to make a few approximations here that may drive your high school math teacher crazy. But that inverse tangent is going to be approximately equal to 1 because this is such a small angle. So we can kind of delete that. The angle is simply rise over run. Now, to be honest, this is a factor of 10. So I will have to multiply by 10. So if we take our example of the Auger spur recovery here, that angle that I'm looking for is 11,000 feet, but we're going to mix our units a little bit, feet and nautical miles. And all I care about is feet and thousands of feet. So 11 divided by 14. Now, I have a couple ways I could do this. I could pull out my calculator, put that in, and I'm going to find out that the answer is approximately 0.8 times 10, 8 degrees. So I need to lower my nose 8 degrees from level flight if I want to get down to spur in time. Now, oftentimes in our airplane, we're busy flying. We have a control stick in one hand. We have a PCL in the other hand. It's not convenient for us to pull out a calculator. So what 11 over 14 is, that's just a proportion. So we can do a visual proportion looking at our attitude indicator. Not the world's best drawing, but it will work for our purposes here. Now, 11248 says that for 200 knots, if I want to be level, that is 0 degrees pitch or line on line, it's 50 plus our altitude in thousands of feet. For descent, it says if I go 5 degrees nose low, the power setting is 20%. A descent with 8 degrees nose low would be 5% torque. And 10 degrees nose low, we have a choice, 3 to 4% or 25% and speed brake. So 11248 basically is saying that the most nose low we're going to plan on going is 10 degrees. So that 10 degree nose low represents 100% of our descent profile. So I want to find 11/14 of that. Pretty simple thing to do. I'm going to take the run, or the 14, let's change our font here, and I'm going to put that 14 on my 10 degree nose low line. Now, proportionately speaking, where would 11 be? Well, if 10 degrees is 14, 5 degrees would be 7, so 11 would be approximately right there on my attitude indicator. Looking over at the right now at the degrees, that looks to me to be approximately 8 degrees nose low. So we got the same answer looking proportionately. Good thing about using the attitude indicator to calculate this is I can update my descent profile while I'm flying. Let's say I determine that I have 8 miles to lose 8,000 feet. Well, 8 over 8, that's 100%. Or if I put the 8 on the 10 degree nose low line, where would 8 be? The 10 degree nose low line. So in that case, I would need to go 10 degrees nose low in order to make my altitude restriction. Now, big thing to remember about this. This is no wind. It also means that I start my descent the moment I get to auger. If I have any delay starting my descent, I'm going to have to use a steeper angle. It also does not give us any kind of a pad or a buffer. As a pilot, I never want to get down to my altitude right at my point. Other factors such as the wind, a delay in me starting the descent, or my inability to hold a constant pitch in that descent could mean that I don't make my altitude restriction. So as pilots, what we really want to do is try to get down a few miles sooner. And how many miles that is depends on your technique. How much time do you want to get down, get stable, look ahead, and be ready for when you get to spur? So our biggest case here is the wind is affecting us. That 150 at 10 headwind when we climbed out now becomes a tailwind. So if I use 8 degrees nose low and 5% with a tailwind, I'm not going to make my altitude restriction. So the way I can fix that is by dropping down one entry in my table. So a good technique, descending from auger to spur on that recovery, I'm going to use 10 degrees nose low and 3 to 4%. I could just as easily use 25% in speed brake, but for me that sounds kind of silly setting a higher fuel flow just to put some drag devices out. But if I pull my PCL back and I cannot get 3% because I'm already in idle because of the conditions, temperature, pressure, altitude, the specific engine on my plane that day, then I could always go to the other technique of 25% and speed brake. So students that say that they go 7 and 7, now that is a technique. If you interpolate, 7 degrees nose low would be about 7% on the power, so that is a valid technique. You won't find that in 11.248 though. But students that say they go 7 and 7 and they're able to make their altitude restrictions, I question that. Mathematically, that's impossible. Usually what those students wind up doing is not holding a consistent pitch. They're probably dropping their nose to 10, maybe even 12 degrees. It bounces around and they're averaging that 10 degrees nose low. That's why they get down in time. So hopefully this is useful for you. It's good for instruments and it's good for contact. Always plan ahead. Always plan and calculate what descent you're going to need for your profile. Don't wait until you get there and try to figure it out. Now, if you're presented with a new situation while you're flying and you have to calculate it flying, using the attitude indicator to set up that visual proportion is certainly a good technique to use. Hope you find this useful. If you have any questions, you may always contact me. I'm Mr. Brown. I'm down in A Flight.